It was our mission at Project Sea Lotus to rid the ocean of oil and trash pollutants. 4 high school teens from different backgrounds joined together to solve the problem of ocean pollution. Since August of 2022, we have worked hard to make this dream a reality. We started out with polling to see who our audience was. We met with different mentors along the way to receive advice and guidance. We built a 2-part device meant to collect trash and oil. Although our design changed a lot through this journey, our final was the most cost-efficient and effective. Our team was determined to assemble our product so we could start testing. To make sure this design was up to par and could meet the predicted goals, we put our device through multiple tests. Our team made a lot of progress throughout the year, finally wrapping up with the in-house expo, and we're excited to showcase our finished product at the final expo. See you soon!
Hi, I'm Ariana Williamson, our team manager.
I'm Ben Lake, the lead engineer.
I'm Serenity Steve, marketing and film expert.
Hello, I am Caleb Linko, our mathematician.
The mission at Project Sea Lotus was to develop a 2-part robot that will clean both oil and trash from our oceans. There is approximately 24 trillion pounds of trash and in between 1.7 and 8.8 million metric tons of oil being dumped into our oceans every year. Project Sea Lotus will lead the world to be a better place and make our oceans cleaner.
100 million pieces of plastic are consumed by blue whales, the largest mammal on Earth, every day. And in 2022 alone, there were 4 oil spills that spilled an estimated 700 metric tons of oil into our oceans. And in the Exxon Valdez oil spill, it's estimated that 250,000 birds were killed. These are the numbers of ocean pollution.
And you may be wondering, what does that have to do with you?
78% of our participants were interested in learning about cleaning the ocean. 73% of our participants would use ocean cleaning devices. 67% of our participants knew about the growing toxins from ocean pollution. Our research also showed that if you consume any animals that consumed harmful pollutants, you could be at risk for health concerns. Laws our team had to be in compliance with includes boat laws that state our boat has to have lights while operating, Subtitle C, which regulates criteria for hazardous waste generators, transporters and treatment, storage and disposal facilities. It also states anyone who collects hazardous waste must notify the EPA or their state agency. Lastly, the Clean Water Act, which allows public participation in cleaning our water.
After reading Coastal and Deep Ocean Pollution by editors Andreas Hugo Arias and Sandra Elizabeth Bott, we learned valuable research info. People heavily impact the ocean with heavy metals and acidification, yet are also impacted in turn as the toxins move up the food chain. We also learned that though oil spills might not happen as often as they seem to be portrayed, they are also still very serious events that should be taken seriously.
That Sea Lotus has on our competitor products is the fact that we are a cheaper alternative. We are less harmful on the environment. We are smaller in size and less dangerous to the people operating and to the wildlife involved. For example, Seabin is just a stationary device. Fred is very big, expensive, and dangerous. And Clearbot Neo is very technical, has a lot of room for error, and is also incredibly expensive. And the one keynote that we have above all of these products is the fact that we focus on trash and oil. None of them do that.
The very start of our project was full of different chances and possibilities, but after doing some research on the price and other components of this design, we realized that this would be an unattainable. We decided to use the advice from our mentor called Marcelo Alvarado. We decided to not reinvent the wheel.
The biggest decisions we had to make through this project were our team names, our team focuses and values, our decision to either create a motor from scratch or use something already made, and as well as adapt our sizes for what would work best to collect the most trash and oil.
The 3 major product parts that we needed while designing this device were 1. Our oil absorbing pads. Our oil absorbing pads were meant to only absorb oil. 2. Our RC boat that we are using as a motor. We learned early on that building a motor from scratch would be too complex, so we decided to not reinvent the wheel. Lastly, our net. that we use to collect trash, with the design mechanism to not hurt any aquatic life in the process of collecting pollutants from the ocean. Our team chose these products that were the most cost efficient and effective to build our device. The total price came to around $155, $85 in contributions to Charlotte Engineering Early College.
For our second prototype, what we had in mind would be a net that would be trailing under and behind the actual boat, but we quickly realized that this had a chance of actually stopping the boat.
We began building our first prototype to prepare for the in-house expo.
Oh, this is great, guys.
Can we make it a little tighter? Well, we have the other one to pass into, so.
Yes.
This is how we executed the design.
So right now we are connecting the arcs together with hot glue because the Gorilla Glue that we tested before just didn't work with what we were doing.
Okay, can you explain to us what's going on right now?
Alright, we have drilled the set of holes on the top, on the other rim. And now what we are doing is basically like setting it up.
At this point, we began attaching our net to the arc. So, can we explain what's going on right now?
We're attaching the boat, we're attaching the string to the net.
Yep.
Alright,
Ha!
we quickly switched to our final prototype, which actually had the net mechanism be in front of the boat, held up by carbon fiber rods and by rims that would be made of PLA 3D printed material, and that this way, as the boat was going through the water, it would be catching a lot of the floating trash that is a lot more present than the trash that would be present at the level under the boat.
Initially, we thought we would be unable to have a physical prototype. However, soon after that, as I thought, we got into planning. And the initial prototype was several.
We weren't able to complete any testing until we received our motor. It took multiple prints to finalize the second prototype, and finally we revised our design multiple times to complete the rebuilding phase.
First things that we tested was buoyancy and speed. How we did this was we did the boat alone for our motor, tested that to see how long it would be able to run and how fast it would go. So, after 15 minutes of a full charge, the boat reached top speeds of 25 miles an hour, and of course it did float. So, after we got this test back, we had to consider weight. Weight is going to be a major factor because we had to add more things on, such as our pads and attachments, and we were concerned if this would impact the speed and efficiency of our craft. Despite following the design process, during our testing phase was when we were able to make gains and successes, but also we were set back. With our earlier worry about how the weight would impact our boat and if it would run or not, the collecting net rings brought on some major complications as the boat, engine, and motor was brought up out of the water and the boat itself was running down into the ground in the shallow testing area. But time was of the essence to get it fixed. Testing is part of the design process, and just because things don't go according to plan doesn't mean you can just give up. Our project mission is necessary, and so we remained hopeful and persevered the challenges our testing presented as they came.
Our 3D printing base holding up against the harsh environment of the ocean water was extremely important. We model ocean water by simulating the properties of the ocean, using 965 grams of tap water and 35 grams of salt to model ocean salinity at 35%. Our results concluded after 24 days of being put in solution, our control group of H2O weighed an additional 8.3 grams, while our independent group of salt water weighed an additional 8.1 grams. This showed us that the material is sturdy in water, but over time the filament will take on water, adding to its weight.
My likes of the in-house expo was that the trailer we had, or the actual video in the back that we had running was very nice. It gave the audience kind of a clear idea of what's going on. What I didn't like is that towards the end, my voice was going a little bit under because I was talking loud for so long, and some of the people were just clearly there just because they had to be there. But
my likes just how smoothly and how quickly everything went. So it's like everything went faster than I thought it would go. And it's like it's just how people go up behind like office is going on. So it's like we're talking as you were in the middle of things. So then when everyone else was involved, so we couldn't get to everyone easily, and that's just when the finals was well. And now I was not like it then, I think.
Yeah.
I think so. So something I liked about the in-house expo, I do like how it flowed like really fast, and then we were able to like get a feel for like how the final expo was going to be. So everyone kind of was like able to see they were good at explaining this, so that's what they stuck with. One thing I didn't like though was also how chaotic it was, because there were so many people like flowing through at once, and then there would be some people that didn't want to be there, so they'd just be standing blocking the way, and then there were some people that would be just too interested and wouldn't move on. So so definitely one of the goals I would have is we just have to we would have to just usher everybody through, so like once we're done explaining, they gotta go.
I guess it's my turn now. Something that I liked about the expo, or the in-house expo, was the setup that we had. I feel like it displayed the progress that we had made so far, and I think people were really intrigued with like the small testings that we had them do. And I just like how like we all looked like a team. We knew our information. It wasn't like we knew when to pick up where somebody was lacking. And I just feel like we had a lot of team unity throughout the in-house. Something that I disliked, like everybody else said, it was a little chaotic, and trying to move people around was very like difficult in a way. And I also didn't love how we didn't have a final product, because that were some things that people wanted to see. So hopefully for the expo we'll be able to have something.
Alright, goals, Caleb, you go first.
Okay, Ghost, I want to go as quickly as smoothly as it is in-house.
We're gonna be there all day.
Yes, I feel like I went for days, so it didn't feel like that long, so I want that to happen again.
My goals for the expo, I want to be proud of the final product that we put on, and just feel like, yeah, we accomplished something. Not anything that we really wanted to do, but something that we're all just proud of in the end. And, you know, I hope everything runs smoothly. Hopefully we get the cash prize, but, you know, it's okay if we don't.
My goals are really just to see school year's worth of effort come to a close. I want that as soon as we, pack up everything, for us to look back on this and be like, wow, that was a great experience, instead of having to worry about the next deadline.
Yeah.
I don't think that this is a great experience.
That wasn't bad.
It was a bad, but it was a great, I think.
Yeah, I think we had good moments and bad moments. I think now that we're towards the end, everybody's a little more tense and stressed, and I feel like that's showing a bit, but I think at the end of the day, we still have a good foundation as a group. And the fact that it's almost over helps it as well.
Yes. That is my goal, to just wrap everything up and just be done. That would be great.
All behind the ball and both behind us.
Drag to the finish line.
But overall, I'm really proud of our group. I feel like I don't think we all would have thought that we would have been working with each other last year and having this dynamic. So I just like how we all are able to put our strengths together and, help each other out when we have weaknesses. So that's overall, I'm just really proud of where we've all come and stuff like that. And I feel like everybody's learned a little bit of skills that they didn't have in the beginning. For me, I feel like helping a part with the testing process and stuff, and having Caleb help me with like the salinity and stuff, I just know a little more about that, so I feel a little smarter now. So that's great.
I do feel like I learned to also rely on other people, because, not to be shady or anything, but I have been in groups where I have to do the whole project myself. So it was nice being able to like divvy up all the work.
I learned to use Inventor a little bit better. Actually, hold on. Probably properly sheets. That's cool. I didn't know about that material that I can actually absorb that.
Yeah.
And honestly, if there was like 13th year Senior EXPO, we would have something really good.
I learned how to work up better. I think work up better and how to focus more on individual tasks and that. But also how much I will for the shoulder project than the hard one.
Yeah.
It's good to avoid any of those.
Good, example of what engineering should be.
Yeah, I really don't like engineering, and I'm majoring in bios. I never thought I would have to do this, but it did give me a respect for people that are going into that field and building and stuff like that. And it's just nice to be able to say that I've done it and that it's done. So yeah.
We did good, guys. High five.
In life, there are always going to be setbacks. At times, our team felt lost at sea, but even through our confusion and frustration, we continue to power full steam ahead until we reach the Senior EXPO. After finally reaching shore, we're proud of how far we've come. In life,
You should have did a fist bump. That would have been way better.
There we go. All right,
Okay,
we're
cool.
done.
That's a good ending.